Earth could be destroyed tomorrow. It sounds dramatic, but the universe is a dynamic, sometimes violent place. The forces that created our world can also destroy it, but the scenarios we'll explore are not predictions, just scientific possibilities. These are real, plausible events, but their chances of happening soon are incredibly small. So why discuss them? Because understanding the risks empowers us, separating fact from fiction. In this video we'll explore 4 global catastrophe scenarios, from space, from within Earth, and from our own technology. The goal isn't fear, but fascination, and a deeper respect for the science that helps us navigate our place in the universe. Our journey begins in the vastness of space, where asteroids and comets drift through the solar system. Occasionally, their paths cross with Earth's, with dramatic consequences. 66 million years ago, a 10-kilometer asteroid struck what is now Mexico, ending the age of dinosaurs and wiping out most life on Earth. The impact unleashed energy equal to billions of atomic bombs, triggering earthquakes, tsunamis, and a global impact winter. Sunlight was blocked, plants died, and food chains collapsed. Could it happen again? Yes, but the odds are tiny. Such impacts are tens of millions of years apart. Smaller impacts, like the 1908 Tunguska event, are more frequent, but still rare. Today we're not helpless. Astronomers worldwide scan the skies for near-Earth objects, mapping threats with increasing precision. The aim spot danger decades in advance, so we can act. Deflecting an asteroid isn't about blowing it up, but nudging it gently off course, years ahead of time. NASA's DART mission proved this is possible, successfully altering an asteroid's path in 2022. While rogue comets or hidden asteroids remain a challenge, our detection systems are improving. For the first time, a species, us, can see cosmic threats coming and do something about them. The risk of a major impact is low, but our preparedness grows every day. Asteroid defense is a quiet global effort, one of humanity's greatest insurance policies. We are learning to be the guardians of our own planet. Now, we turn inward, to a threat of our own making: nuclear weapons. A full-scale nuclear war would unleash devastation beyond imagination. Cities obliterated, millions dead in moments. But the true global threat is what comes after nuclear winter. Firestorms would send black soot into the stratosphere, blocking sunlight for years and plunging Earth into a man-made ice age. Crops would fail, ecosystems would collapse, and billions could starve. This is a catastrophe engineered by human hands, a failure of wisdom, not technology. The risk isn't constant, it rises and falls with global tensions. While arsenals have shrunk since the Cold War, the danger remains. Miscalculation, escalation, or error could trigger disaster. Unlike asteroids, we can't build a shield. Our defense is diplomacy, communication, and trust. Arms control, de-escalation, and transparency are our best tools. As long as nuclear weapons exist, the risk is never zero. The only true safety is their elimination. Nuclear winter is a stark reminder: in the nuclear age, there is no over there. We all share the same fate. Our survival depends on empathy, reason, and the will to avoid self-destruction. The threat is real, but so is our power to prevent it. Now, we look beneath our feet, to the restless power inside our planet. Earth's crust floats atop a churning mantle, and sometimes pressure erupts as volcanoes. But some volcanoes are in a league of their own. Supervolcanoes, these vast calderas, like Yellowstone or Toba, can unleash eruptions thousands of times larger than anything in recorded history. The Toba eruption, 74,000 years ago, blasted ash worldwide, dimmed sunlight, and may have nearly wiped out early humans. A super eruption today would devastate continents, disrupt global agriculture, and plunge the world into years of cold and darkness. The ash would choke machinery, poison air, and sever supply chains. When will the next one happen? We don't know. Geological timescales are immense, and these events are extremely rare. Yellowstone's last major eruption was 640,000 years ago, but that doesn't mean it's overdue. The annual odds are minuscule, but the consequences are so vast that science takes the risk seriously. Supervolcanoes are intensely monitored. Seismometers, satellites, and gas sensors watch for warning signs. A super eruption would not be silent. There would be weeks or months of precursors. The challenge. How do you prepare for a disaster on this scale? The answer is vigilance, constant monitoring, early warning, and robust emergency planning. The dragon sleeps, but science stands guard. Our final threat comes from the star that gives us life, the Sun. The Sun is a turbulent ball of plasma, and sometimes it erupts, sending solar storms toward Earth. The most dangerous are coronal mass ejections, CMEs, which hurl billions of tons of magnetized plasma into space. Earth's magnetic field usually shields us, but a powerful CME can overwhelm it. The danger isn't to life, but to technology. A massive solar storm could induce currents in power lines, frying transformers, and crippling electrical grids. This isn't just theory. It happened in 1989, when a solar storm blacked out Quebec in seconds. The worst on record, the Carrington event of 1859, set telegraph offices on fire. If a Carrington-class storm hit today, it could cause continent-wide blackouts lasting months or years. No electricity means no water, no refrigeration, no internet, no modern medicine, a collapse of civilization's backbone. Such storms are rare, but inevitable over centuries. In 2012, we narrowly missed a Carrington-scale CME by a week. Our defense is vigilance spacecraft like SOHO and the Parker Solar Probe monitor the Sun, giving us hours to days of warning. This time allows grid operators to take protective measures and engineers to design more resilient systems. The Sun gives us life and reminds us of our technological fragility. We've explored cosmic impacts, supervolcanoes, nuclear winter, and solar storms. Each is sobering, but the odds of any happening soon are extremely low. The point isn't fear, it's understanding. Science is our greatest tool. It lets us see threats, prepare, and even prevent disaster. Our ability to imagine these dangers is proof of how far we've come. Awareness makes us stronger,